In the 21st century, NASA and ECA declared a mission to Mars as their primary goal. The idea of bringing an expedition to Mars is the first step in colonizing the planet. However, a closer goal is the direct incorporation of the human mind in the exploration of Mars as part of the world around it. But everyone is aware of the fact that there is no water on Mars. This planet is dry and lifeless. How will humans then address the issue of water, the basis for life? Well, not bring it there with them. And what if our assumption of a waterless surface of Mars is wrong? What if the red planet has a water supply that, if properly treated, could support a full-fledged life in a new colony? How is that possible, you ask? Let's find out. Exploration of Mars began long ago, as far back as 3,500 years ago, in ancient Egypt. The first detailed reports on the position of Mars by Babylonian astronomers, and since 1960, the launch of unmanned interplanetary stations to study the planet, first from a flyby path and later from an artificial satellite orbit, and directly on the surface. Interestingly, in 1892, French scientist Camille Flammarion wrote that the channels on the planet's surface as seen through the telescope resembled rivers and resembled man-made ones. It was suggested that members of an intelligent could use them to redistribute water across the dying Martian world. But 3 years later, the English astronomer Edward Maunder was convinced that the linear objects were simply the summation of many small details, creating an optical illusion. Nevertheless, the question of water on Mars never left the minds of scientists. So is there water on the neighboring planet or not? Scientists believe that once upon a time, the planet Mars, water, and there was so much water that the depth of an uninterrupted oceans could range from 100 to 1,500 meters deep. However, about 3 billion years ago, the planet lost its atmosphere, and that led to the disappearance of all the liquid. As a result, Mars today looks like what we, as spacecraft, show it to us today: a cold desert with occasional dust storms. According to the study, giant columns of dust during storms on Mars can reach heights of up to 80 kilometers to act like space lifts, throwing everything on the planet's surface. On Earth, a storm tends to be concentrated in one area, but on Mars it's a little bit different. About once a decade its entire surface is enveloped, a global storm that lasts for several weeks. For example, such a storm was observed in 2018 when Mars was covered in a yellowish haze. As the study shows, the dust columns are much denser than the usual dust clouds that are present in the atmosphere of Mars. They also rise much higher than the dust clouds. These giant columns can not only occur during a storm, but it's during a global storm. These dust columns have bases up to 90 kilometers in diameter, extending upwards to 600 kilometers, and spreading out dust from the planet's surface over an area over 4,000 Kelvin in diameter. In 2018, the global storm that produced lasted almost 4 weeks. The planet surveys used extensive, multi-year datasets obtained with the SBICAM of the Mars Express Orbiter. A high-resolution stereo camera aboard the spacecraft captured the rising dust cloud front near Mars' northern polar ice cap. Along with the dust, moisture is also being drawn from the planet's surface. The dust columns, like a space lift, lifted into the layers of the atmosphere where solar radiation breaks down the water molecules into space. It is very likely that this is how Mars lost all its water. For a long time, scientists were convinced that water on Mars disappeared by evaporating. The Earth has a magnetic field, or magnetosphere, that keeps the atmosphere from escaping into space. Mars has a weak magnetic field, and apparently it couldn't to hold water. but the speed at which hydrogen, which is part of the water, is escaping from the atmosphere of Mars. That the history of the Martian oceans is much more complex. If you take it for granted that today, hydrogen is escaping at the same rate as in the past, then, according to study co-author Eva Lingen-Skeller of the California Institute of Pasadena Institute of Technology, Mars would have lost very little water. In other words, most of the water must have to go somewhere else. Scientists have recently studied scientific data from spacecraft and have suggested that up to 99% of the water has simply been absorbed into the surface layer of the planet. The Mars Odyssey artificial satellite has discovered that there are deposits of water ice. This was later confirmed by other spacecraft using a camera that produces an image based on analyzing thermal radiation. The question of water on Mars was finally settled in 2008 when the Phoenix spacecraft, which landed in the polar region of the planet from the Martian soil. The authors of the study suggested that Mars lost most of liquid water between 4.1 and 3.7 billion years ago, in a historical interval known as the Noachic period, characterized by intense meteoroid-asteroidal bombardment and an abundance of surface water. At some point, the planet Mars lost its atmosphere is a fact. What caused it, scientists do not know exactly. In 2017, researchers studied data sent from the spacecraft orbiting the red planet, MAVEN. They concluded that much of Mars' atmosphere, Mars has disappeared due to the effects of the solar wind. This is evidenced by the fact that, over the years, most of the argon gas had escaped from the atmosphere over the years, and it, because of its properties, could only be blown out into space by solar winds. Anyway, due to the disappearance of the atmosphere, the water molecules on Mars were interacting with the sun's ultraviolet light to break down into oxygen and hydrogen. That, at least, was long believed by scientists. It was said that this process led to the disappearance of large quantities of water. However, it's recently come to the attention of researchers in the United States that orbiters are still detecting the evaporation of hydrogen. This means that there are still water molecules on Mars, of water that interact with the sun's rays and break down into its constituent parts. Unfortunately, at this point, scientists have not studied Mars well enough to be able to say with complete certainty, but it will be possible to verify this assumption by the results of the Perseverance rover. As we already know, the rover is located of the A0 crater. Scientists are inclined to speculate that it was once filled with water and was inhabited by microbes. It's possible that the crater's soil still contains more than 3 billion years old. After studying the samples, scientists will be able to tell exactly how the water ended up in the soil. The main initial goal of Mars exploration was to look for water because it plays a key role in geology, climate, and the very beginnings of life, explains Dr. Michael Meyer, who heads up NASA's Mars Science Program. The results of the new study suggest that a lot of water, perhaps most of it, was bound up in Martian minerals, as Dr. Grindrod. As a result of the hydration process, the formation of water dissolved in it. There may have been large quantities of water, up to a layer a kilometer deep, covering the entire planet. Well, we're left to speculate today what Mars was like in ancient times, when the pleasant sea breezes of the sea brought a special freshness. Perhaps someone might even have enjoyed them. Who knows? Perhaps when man has mastered the full extent knowledge of the climate, rivers will flow again on Mars.